Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about instantaneous rates of change.
Minute Math, when you need help you use Minute Math.
We're given this function right here, y equals x squared plus x plus 2. And we want to find the equation of the secant line that intersects our given points, -1, 2, and -1/2, 7/4, as well as the tangent line that goes to the leftmost point, which is -1, 2. We got to sketch both of these lines. Now, we can see our graph for our equation right here. Okay, just briefly, I'll put it away in a second. And we want to go first let's go with the secant line first. So let's do the secant first. Equation of the secant line. Well, we want to find our slope using our slope formula. Pretty easy. We're given the 2 points right here. 7/4, this is just algebra, guys, minus 2 over a -1/2 minus a -1. y2 minus y1 over x2 minus x1. This comes out to be a -1/4 over a 1/2, which is a -1/2. All right, we got our slope here. Our formula for y equals mx plus b, so we have y equals a -1/2 x plus b. And let's go find, well, the equation of the line. We can use the first point here, -1, 2. I think it's the easiest. And this, again, is just algebra. You should know that. -1 over 2 equals -1/2 times our x value, -1, plus b. And this comes out to be a b value of 3/2. I won't bore you with that part. So our b value is 3/2. So our equation of the secant line just comes out to be a y equals our slope, -1/2 x plus a 3/2, which is our b value. So that's the equation of the secant line. Now we want to find the equation of the tangent line, and we're going to use our definition of the derivative to help us out there. So it's going to take some work here. So right here, let's go with the tangent line. Right here. And our first step, let me kind of mark that off. First step, we want to find, well, the derivative of our function. So our definition tells us that f prime of x is equal to the limit as h approaches 0 of our function right here. But we're going to put an x plus h in for x. So we have an x plus h squared plus an x plus h, I'm running out of room here, plus 2, minus, I'll shove it down here a little bit, we have the x squared plus x plus 2. All of that is over our h value. Okay, so I'm going to let's do this so I have a little more room here. Let's go simplify that. The limit as h approaches 0 here, okay, what we're going to do is really, I'm going to multiply a whole bunch of stuff out in that numerator. Okay, so that x plus h all squared comes out to be an x squared plus a 2xh plus an h squared. Then we have a plus x plus an h plus a 2 minus an x squared minus an x minus a 2. Notice we have to distribute here all those parts. All of that is over h. Okay, so it's at this point I try to see if there's things that I can cancel. X squared here cancels with this negative x squared. X and a negative x, and 2 and a negative 2. So let's get a better picture here. We have the limit as h approaches 0 of a 2xh plus an h squared right there, plus just that h. And all of that is over this h. Now, if you need help seeing this, but I'll take the time. This one's a little tricky, actually. Usually you can cancel all these out, which you can, but just be careful, that's going to be a 1. We're going to just pull out the, well, h's here. Right, you'll see that here. And pull out h in the numerator, so we have an h out, we have a 2x plus a 1h plus a 1 over the h. And this is where you can see the h's cancel pretty easily. So if you can do it within it, great. If you need that step, fantastic. It's all good. Keep on going here. We have the limit as h approaches 0, and we just have a 2x plus h plus 1, and it's at this point that we can take the limit directly. Taking the limit directly, we plug 0 in for h, we just get a 2x plus 1, and again that's equal to our f prime of x. Now they tell us we want to find the equation line at the leftmost point, so that's a -1, 2, and we want to find the slope there at, well, the x value, -1. So that's all we care about. We take our f prime of -1 and put that up here, f prime of -1, And that's going to be a 2 times a negative 1 plus 1. Well, that comes out to be 2 times a negative 1 is a negative 2 plus 1, and we have a negative, well, 1 here. So our slope value here, our m, is negative 1. So now it's the same process as before. We have y equals our slope negative 1, slope times our x value plus b. Now, here's a tricky point. We have to use our point to find our b value, and we have to use this coordinate point there. Okay, the first one. We don't have the option of using both here. So 2n for y equals a negative, 1 is a negative, times x value negative 1 plus b. And that comes out to be here a b value of a positive 1. And so our tangent line, I'll put that over here, our tangent line, combining it all together, is a y equals a negative x, the m value, plus 1. Okay? Now, when we bring the graph back up, we might cover some of the stuff here. With the graph back up here, and what can we see? Well, we can see our equation of our line, x squared plus x plus 2, and what we have is the tangent line, the secant line between the intervals negative 1, comma 2, and negative 1/2, comma 7/4, as well as the instantaneous rate of change happening at the tangent line at negative 1, comma 2, with our second equation here. And so our two equations, to sum it up here for the secant line, our secant line is y equals negative 1/2 x plus 3/2, and our tangent line is equal to y equals negative x plus 1. I hope this video is helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.